Hey everybody, this is the final prototype review for our senior mechanical engineering design project. We made a robotic bartender, the MIXoTRON. My name is Christina Bell.
I'm Devon Roell.
My name is Dani Stone.
This is our project statement. Bars are a great setting for friends to meet and drink. However, there aren't many special features that set one bar apart from the rest. What you won't find in any bar today is a robotic bartender able to make any drink to order. In addition, there are many ways to make certain drinks, allowing for much variation. Automating the cocktail making process eliminates the variation in alcohol levels and ingredients used. In addition, it guarantees that your drink will not have anything in it that the customer does not explicitly see. Giving the customer options of existing drinks and customizable features will ensure a smooth and enjoyable drinking experience for everyone.
Here is an isometric view of our prototype. The ultimate function of this device is to mechanically make a drink comprised of 2 different ingredients. The device can hold a total of 6 bottles. Each bottle has a volumetric valve that, when pressed, will dispense 1.5 ounces of liquid. We have 2 mechanical processes at work to make this happen. The first is a powered turntable that will orient your cup under a specific bottle of your choosing. The second is a powered lead screw. This will drive the carriage holding the bottles downward into the cup until the volumetric valve is pressed enough to dispense the liquid. The lead screw then drives the carriage upwards away from the cup, and the turntable will orient the cup under a different bottle. The process repeats until a recipe is completed. We have yet to pre-program recipes into the device. To prove the concept, we have a keypad programmed with 4 basic functions: moving the carriage up and down, and turning the turntable clockwise and counterclockwise. This is a picture of our final prototype.
Our 5 performance goals are as follows. It'll be able to complete 1 drink in less than 30 seconds. It'll be able to make 20 drinks before switching batteries. It'll be able to be disassembled and reassembled in 5 minutes by trained personnel for cleaning and minor maintenance. It'll be able to make 5 different drink recipes, and it'll be able to make 8 drinks without having to be manually recentered.
On average, it took the prototype 1 minute and 30 seconds to make 1 drink. This is 3 times as long as we had hoped for. During research and customer interviews, we found that it takes the average bartender roughly 1 minute to make a more complex cocktail. Thus, our prototype is still unsuccessful in comparison. There are a few ways we could speed up the device. First, we could redesign the gears on the lead screw so that the gear ratio is numerically closer to 1. This would step down the torque, but would increase the speed of the lead screw. We could also use a lead screw with a steeper thread pitch, or simply buy a more powerful motor. To analyze our second performance goal, we found the total current draw of each electrical element used to power the device. Our prototype is currently powered by 8 AA batteries with a service life of roughly 1 hour of continuous use. Doing a bit of algebra, we estimate that we can make 40 drinks with our prototype before having to switch batteries. To test the third performance goal, one member of the group was tasked with disassembling the prototype to the extent of basic cleaning and maintenance and reassembling it again. This would be the kind of task that a bartender would have to perform if the device were at a bar. In total, the task took about 1.5 minutes, which is 30% of the 5 minutes allotted. We defined one mixed drink to be a mixture of 2 ingredients. While the carriage is designed to hold 6 bottles, we only tested with 4. Even still, using a permutation of 2 choices of 4 ingredients, we can make a total of 12 different recipes. If we further define one mixed drink to be comprised of exactly 2 different ingredients, we reduce our menu to only 8 drinks. This is still greater than the 5 we expected. Unfortunately, the 5th performance goal is automatically a failure. This goal was directed at keeping the error down when pre-programming drink recipes. We were planning on using light sensors to detect when the cup was under the correct bottle. We expected a small amount of error in this process, and expected that the error would accumulate over time, and eventually need to be manually recentered to keep the device in working condition. Since we do not have recipes pre-programmed, this goal is untestable. Overall, we consider this project a qualified success. We have met or exceeded 3 of the 5 performance goals, and have plans to improve upon the 2 that failed. We would like to thank Dr. Potter, Dr. Malist, and Professor Asanugo, our senior design instructors, for helping us through the design process this semester. Thank you for watching.